Welcome, everybody, to our next talk, which is about taming Postgres extensions in Kubernetes and, in general, strategies for dynamic management of those extensions. One thing I want to mention at the very start, viewer discretion is advised. We use a lot of AI-generated images, but no elephants and no octopi were hurt during this presentation, just FYI. All right, my name is Szczepaniak. I am a senior product manager at Percona, working on our cloud-native solutions, and I brought my good buddy with me today.
Hi, my name is Jan Wieremiewicz, and I'm also working at Percona, working on our PostgreSQL distribution and the extensions we are working on for PostgreSQL. So,
Prawo, lewo.
The importance of PostgreSQL extensions and why at all are we talking about this here during this presentation. So I guess the data on Kubernetes is strong at this crowd. I'm not necessarily sure that everybody here is a PostgreSQL user, so let's maybe go through a very short introduction. Why are we at all speaking about extensions? So extensibility for PostgreSQL, from my perspective, is one of the main reasons why this database is so popular these days. And it's one of the most popular databases out there, and we'll get to that in a second. And if you go through the available extensions, they go through everything ranging from maintenance and administration tasks through adding new data types and making the PostgreSQL a perfect example of a multimodal database. And actually, pgvector is a very good example of how quickly PostgreSQL stepped up the game when it comes to generative AI. But then you even look at, well, if you know me, I've been whining about the lack of data at rest encryption in PostgreSQL, and it allows you the extensibility to actually change things like that, and it allows us to write extensions to change this lack of encryption by adding an extension that introduces it. It allows other companies to work on extensions that make backup, an enterprise backup, a gap that's closed for PostgreSQL. I don't know whether I can play this here. You cannot hear that. It's a piece of a musical. I won't sing. My wife forbids that.
Thank
you. She might find out. So everything you can do, I can do better. That's basically something that I think about when I think about PostgreSQL extensions, because you take the database that's been made 25 years ago, and you see that it grows all the time without the direct use of the developers in the core development team. And with this extensibility, we get to a point where you see that PostgreSQL is actually maybe not the most popular open source database out there yet, but it's definitely the one that's most popular among the developers. Looking at the growth of PostgreSQL, you see constant growth, and it can be widely attributed to the fact that if a new use case appears, the database can step up the game. The database can address the needs of the users that actually need that. But to do that, you do need the extensions. So you do have extensions that come with the PostgreSQL server. There's like 48 modules, and largely these are extensions that come packaged together with the server. And whenever you deployed PostgreSQL from available packages, you most likely, you definitely have installed these. You may not have used these, but they are waiting for you if you need to use specific capabilities. There are also a lot of extensions out there, and these days when I don't know how many or whether there is something available out there, I ask AI. I guess I'm not alone in this, and even AI cannot give me the exact answer. I tried. Maybe I'm not the best prompt engineer, but I got to a certain number. That being said, this number is also not true, because with open source, you think about how many forks are out there of these extensions because somebody didn't like something and scratched their itch and just didn't share it with everybody, but maybe they wrote an extension that they just use internally. There's a lot. Let's say a lot is a good enough approximation right now. So how do you know which ones to choose? How do you know which ones to trust? How do you know that if you choose an extension, if you finally find it, that it's not going to disappear tomorrow or in a week, or if there's a CVE is going to be fixed. How do you know that it's going to be maintained and the new version is going to support the new PostgreSQL version that's coming this fall? How do you know it's going to happen? There's no way of knowing, right? This is the nature of open source, rightly depicted by this cartoon here, right? There may be one guy that actually just maintains this particular extension of yours that is critical to your business. And, well, it should be our shared responsibility to step in and somehow help. And there are ways that we are trying to, we as the overall global community trying to do that. David Wheeler and the PostgreSQL Extension Network, PGXN, is one way of providing a way to find extensions, to find a registry of extensions, to be able to search it, and this is one of the available registries out there. And obviously there's more. What happened to the image here? There's an elephant. You have to trust me on that. Oh, no, it's here. So, and there's a lot of other efforts, yet none of these is dominating enough to call it the one true place to go and find all extensions. All of them are limited. You may have recalled the previously generated AI image from ChatGPT that actually listed all these, and none of them covers even the full 151, I think, approximation that it gave extensions out there. So finding them won't be possible. Also, those registries do not guarantee you that, well, if a developer is sick or something worse, or maybe they are just bored and they're a single developer of the extension, that somebody is going to maintain it. So there is a currently very interesting set of meetups around the future of extensibility. What we can do around extensions, how can we make them easier manageable? How can we make them easier to use? How can we close those gaps and those problems around them? It's an ongoing effort. There's a QR code that you can scan and join a freely available extension. And now I'm getting to the point where, okay, the second challenge is somehow related to, the first one was somehow related to the Kubernetes. The second one is very clearly related to Kubernetes. As with classic installation, you deploy the extension through a package manager. You immediately get security given by the operating system, validating the packages. You get the, if you use the package manager, you use repositories that you trust. So there is extra trust given to the packages you receive. Okay, so what if you just want to use a certain extension on Kubernetes that's not provided together with a server? How do you get it there? Well, you should have a dedicated image. That would mean that if you're in a company that has, let's say, 5 different development teams, and all of them have different set of extensions needed for their deployments, you either have one huge image that has all, maybe not the best solution, or you have 5 different images. Well, that's a maintenance cost that not everybody wants to actually have. So you can go with the dynamic loading that is out there, and that's, well, it's a bit bypassing the operating system. And there is definitely a way to go with images with extensions without repository. My buddy here is going to go over these in a bit more details for you. Please take it over.
All right. Thank you, Jan. You can definitely tell this guy is very passionate about Postgres. So let's maybe sum it up a little bit of the rant that Jan just ran. What are the issues that we are actually facing, right? Postgres loves extensions. Extensions are a key part of success of PostgreSQL. And traditionally, you install extensions via packet manager, apt-get, or whatever else your Linux distributions allow you. But since for security reasons, containers are always run in a non-root, this is not possible and not that straightforward. And it makes it really difficult to support dynamic workloads, especially where a user might need a different set of extensions per different database or a database for different environments. Right, so there is a big principle coming from Kubernetes. Kubernetes really emphasized the immutability of the images and the infrastructure. And all of the container root file system is read-only, and it's mainly to provide the security. This is one of the key principles of Kubernetes. It also enhances the change management by preventing any unauthorized modifications to the image or to the container. Well, with Postgres, we have a bunch of extensions like PostGIS, Timescale, pgcron, that need actually to install control files. They need shared libraries, DLLs, or other dependencies in Postgres lib and shared directories. So this is where those two worlds really clash hard, right? Because since Kubernetes enforced the immutable images, these extensions cannot be installed dynamically or run using create extension unless they were baked into the image. So let's talk right now a little bit about what are the options. What are the solutions that we have? Well, the first one that comes to mind is rigid database image management. I just bake in all the extensions into my PG images, and then when I deploy, I always know that they are there, right? So it kind of looks like the only workaround, the only reasonable workaround, but this leads to a huge image bloat, especially depending on the number of teams that are working and the different extension that they are using. And this introduces a huge complexity to version management, to upgrades, and basically, yeah, you need to maintain many very similar images that have just little minute differences. But doing it this way, it also brings a security and compliance risk, right? Modifying manually running PostgreSQL container, mounting an external volume to pull extensions from, violates the Kubernetes best practices. And also many organizations have a requirement that each container image needs to be scanned, verified, and make sure that it doesn't include any CVEs, any vulnerabilities open. Which again, when you take it in consideration, building multiple images that are very similar, it just exponentially increases the amount of work that is needed and the cost associated with this. Right, so what are the other options? One of the options is propose enhancements for dynamic extension loading. How can we actually make this happen? And I'm going to bring a couple examples from Postgres operator providers, how they are handling the extension issue. And you'll see that each one of them is handling it a little bit differently, and there are some differences. And I believe that making this unified way will benefit all of us. Right, so looking at EDB, how do you extend Postgres with EDB? Well, they suggest using lightweight extension images, so creating the minimalistic images containing only the desired extensions. They also have a declarative deployment, so utilizing Kubernetes manifests or YAMLs, we can specify which extensions we want to use, making sure the consistency and repeatability of those images and those actions. And so how the workflow looks like? Well, the cloud-native PG operator will do the mounting of the extension images for us, and will configure the PostgreSQL to load those extensions from the specific paths, streamlining the process a lot, for sure. Let's look at Stackgress. Stackgress also offers a bunch of built-in extensions, and they also introduced a little bit different way to dynamically load and unload extensions from the file system. Yeah, and you can do it via manifest or Stackgress web console. Okay, moving next, Percona operator. Percona decided to do a little bit of both. So we have both built-in, most popular extensions, and they're built-in, certified, and tested with each of our release. But we also have a way to add custom extensions, similar to Stackgress, but again, a little bit different. And I believe this is where the actual pain is, that every provider deals with the problem on their own, how they think, and this creates disparity. All right, so from those examples, we see there are two vectors that we can try to address this issue. First one is enhancement on the Kubernetes side, basically allowing something like image volume resources. It allows you to mount an additional container images as volumes and allow you to load the extensions while the main image of Postgres keeps the immutability as Kubernetes requires. And the second enhancement is on the Postgres side, which is extension control path. And this feature would allow Postgres to recognize extensions from alternate, possibly writable directories and allow to dynamic loading without, again, altering the base image. What's really cool is, and there was a pretty recent commit that actually allows extension control path to be specified. But I believe it's going to be available in Postgres 18. Jan can correct me if I'm wrong, which means until enterprises and we can actually use this in production, there's still a long way to go. So, what is the future of Postgres extensions, Jan? How do you think?
So, if you go one more slide, so you can see this comment that has been already merged. It basically gives another place in PostgreSQL where extensions can be stored. So, in a way, the original design comes from the package managers that some Linux distributions already had. So Debian, for example, did it in a similar fashion for a while. So inspired by this, the new place can actually utilize the image volume that Piotr mentioned. The problem from my perspective is that it does not solve everything, because it still requires you to have packages that you trust, packages and extensions that you trust. So one vector, one challenge that I've mentioned is actually solved. Here, Peter addressed the challenge number 2. What's going to happen with challenge number 1? Are we still going to rely on companies providing builds and building trust with the companies, or is in time a organization going to shape itself the way we have CNCF, a branch of Linux Foundation, taking care of Kubernetes and giving you guys here the trust that the project is not going to die, and when you come here, that companies are not going to promote only their stuff, but are actually going to talk about technical things. It gives you the trust and some sort of boundaries for the community. This is something, in my opinion, still missing for extensions, but the improvement looks very promising in terms of the usage on Kubernetes. So let's say the main problem we challenge here, how to use extensions on Kubernetes, has been, in a way, hopefully solved for PostgreSQL 18, and looking at the adoption rate of companies and enterprises within the next 2 years, I hope that the Pareto rule 80-20 is going to be 80% of people use actually the version that has this out there. Well, okay. 2 years of deployment. So the conclusion is that the Kubernetes immutable infrastructure clashes with the PostgreSQL extensibility model, and it requires a solution that will retain the benefits of immutability while making Postgres extensions more flexible, manageable in the cloud-native environments. And it's actually up to us, the community. That's why Jan mentioned the meetup that is there. It's up to us, the community, to drive this change and make sure that this process is unified and clear for us to use and rely on. All right, that's all we got for you folks today. Thank you very much. If there are any questions, we're happy to answer.
Questions?
Yep. Any questions? Cool. I mean, we nailed it. There are no questions.
I'll have one.
Thank you very much. I'll have a great day.
I'll have a question. I think it's important to emphasize that we need to work as a community to improve also the PostgreSQL software as well.
Yeah, exactly.
For this specific case, we had helped to move the mindset of the PostgreSQL community towards a more cloud-native approach, using the path
I think it's actually a very good example of communities working together, but I would not be as optimistic because PostgreSQL community shares a number of contributors with kind of prominent people within the DOK community. And without this would not have happened. Yep. To be honest, from my, well, I will be pessimistic or maybe be realistic here. I do not see this happening for the DOK community and the Kubernetes itself. I don't see some changes happening there that should have happened for the like 5 years ago already, let's say, right? So we still have ways to go to make cross-community engagement and collaboration happen better. It's too intimidating sometimes to engage a new community and make changes that happen.
Yep, you're right.
But kudos for us for making the first step.
Thank you.